Hello, everyone. Welcome to this webinar, the Iliad webinar series. Today, we are going to talk about data visualization. My name is Bente Lilja. I run a company called BLB, research and consultancy dedicated to Earth observations particularly, and of course, digital twins of the ocean. Today, we have a very interesting panel with experts on visualization. And the day, as normal, we will have short presentations and then a discussion at the end. We really want you to be engaged with us. So we encourage you to use the chat to ask questions and comment. And in between, well, actually during the presentations, we will publish a small, simple little poll that we would be very happy that you respond to. It's very short. And then we share the results afterwards, and maybe we have some interesting topics to discuss based on that. This webinar, as usual, is also recorded, and the presentations will be made available for you on the Iliad website. We will share links in the chat as we move along in the webinar. With that, I would like to introduce the program in more detail, and also then a little bit about Iliad. So just hold on. You should be able to see my screen. This is today. I will start with an introduction to Iliad and digital twins. Then we jump into why use immersive environments to visualize data by Fernando Cassola Marques from INESCTEC. And then introducing GeoViz, 2D, 3D, 4D Microparticles visualization platform by Jacopo Fabrini from BUAS. And then it's Breda, University of Applied Sciences, sorry for the acronym there. Then we have Renewable Energy Twin and user Procedural Ocean Tool, which is very exciting. It's one of the Iliad pilot twins that demonstrate a use of a new tool that is being developed, among others, through the Iliad project. And of course, then we have the discussion where we welcome your questions, some further comments and information from the presenters, etc. So a digital twin, a very quick introduction for those of you who are not familiar with this topic. So digital twin is something it's not really a new technology, but it is there because we have so much data now, and we have the technology to actually start producing digital twins. So it tells us what now, what next, and what if. And it's not only what if and modeling into the future, but is also actually taking into account what happened in the past. And as you may know, the data from the past is not so easily accessible all the time. It requires some transformation from PDF or whatever format you have, so that it can be integrated in digital twins. And we also have lots of data surrounding the ocean, so non-geophysical and non-biological data, for instance, risk data, statistics, economic data, etc. All of this is then integrated in a digital twin so that we can have a very powerful decision-making tool, but also for scientific use and many other uses. So here you see on the right-hand side some definitions that is being developed continuously, actually, in those standardization bodies so that we can agree on a specific way of defining it. That's a quick overview of a digital twin. In Iliad, this project, Iliad Digital Twins of the Ocean, it's all about enabling this ecosystem of interoperable twins, digital twins, by connecting existing resources and add something new from, for instance, sensors and also citizen science. We want to make it easily accessible, so we are creating a marketplace where you can find the digital twins themselves, but also the components they are composed of. And access, or also you will be able to find data. Now, all of this, of course, is then presented and supporting solutions and finding solutions used for solutions of societal challenges. Our approach, as I said, is really recognizing the vastness of the ocean and the complexity of it. It consists of so many different components, so geophysical, biological, etc. And importantly, it interacts also with the human activities. In Europe, we have several initiatives, a lot going on digital twin now. We are using it in different language, but it's all about combining all of these resources. We align, or it's necessary to align with all the activities in the ecosystem, and therefore we are focused on using standards and best practices. As I said, we multiple twins. So in Iliad, we have thematic twins, and you see here 12 areas that we have divided it into, but there are many more. They are local twins and thematic twins. It covers existing wind farm capacity. We will see an example of a wind farm technology here today, aquaculture, fisheries, etc. At the core is getting the data from where it's produced, transforming it so that it's usable, and then presented in a way that is understandable. And today we are talking about how we are presenting it. The visualization is super important to actually be able to extract the information and the value of the data and all the processing and algorithms that's going on. In Iliad, we have also some focus on the innovation part. So we have the academy, so all this recording from the webinars, they are very often very educational. So we collect this in an academy, we support the business. Also policy is important. And as I said, we have the marketplace. I don't want to bother you with this architecture here, but the point by seeing that, if you notice that there's layers here, and it means that we are making the twins interoperable. Here is the architecture again. I will jump this and then just remind you that this is a big investment from the European Union. It's a project, it's a Horizon 2020 Green Deal project with close to 19 million euros with 56 partners. And we just are towards the end, the last year of the project. So with that, I will then go over and present the presenters. Here you see a little bit more information about me. I already introduced myself, so I will skip that. And we go directly to you, Fernando. Fernando Cassola, he's a researcher at INESCTEC in one of the Iliad partners. And he is also a visiting professor at the Faculty of Engineering of the University of Porto in the area of software development. His expertise lies, well, in computer science, but also, of course, why we are having you here is that you know visualization and particularly immersive environment, Fernando. So with that, I give the floor to you.
Okay, thank you, Bente. Let's share my presentation. Just share screen. I think you are right now. You are seeing my screen, right?
Yes, yes, we are.
Okay. Well, so let's start. The title we gave to this short, brief presentation is why using immersive environments to visualize data. Well, immersive environments offers, let's say, a unique and effective way to visualize data due to several key benefits, I think. So let's see a couple of them, okay? Well, first of all, immersive environment could be used to an enhanced engagement. Let's say the immersive visualization tools allow us users to engage with data in a more interactive and engaging manner, let's say, which can lead to better understanding and insights. The use of XR technologies, such as augmented reality and virtual reality devices, under the virtual worlds concept, it can provide a new and unfamiliar environment that is associated with higher levels of excitement, engagement, and I think entertainment also. Such effects certainly help users to keep their attention and visualize information. We have seen this IBM immersive data visualization. Another type of, let's say, immersive environment could bring to data visualization is a multi-dimensional experience. Unlike traditional 2D visualizations, immersive environments enable users to experience data in 3 dimensions, providing a more holistic view of complex data sets. We are seeing a practical example of this technology. The data dev project team created a really interesting platform that allow users to easily incorporate immersive visualization, including IR and VR headsets, into their existing workflows, seeing their data immersively with real 3D visualization. We could see it in laptops, touch screens, tablets, smartphones, and more. It's genuinely impressive and powerful also. Well, another key point is that immersive visualization, data visualization could improve scale perception. Immersive technologies can represent large-scale data sets more effectively, allowing users to perceive and analyze data that would be difficult to comprehend in a 2D screen, let's say it. There is a research about the improved scale perception in immersive data visualization conducted in the Hong Kong University, but because they explored how different designs affect the efficiency and accuracy of scale perception in immersive visualizations. The Flow immersive platform that we are seeing, for instance, exemplifies how immersive technologies can be utilized to improve scale perception, allowing users to interact with and comprehend large-scale data in a more intuitive and meaningful way. Let's jump into another approach. Well, also immersive data visualization can improve scale. Sorry, I jump in. Immersive data visualization can be used also because they are provide intuitive interactions. Well, navigation and manipulating data in an immersive environment can be more intuitive as it leverages natural human spatial awareness and interaction capabilities. We talked already and seen about interesting projects that fits exactly in these intuitive interactions, such as IBM immersive data, the Tableau for HoloLens, etc. They provide natural user interfaces in a multi-user environments that demonstrates how immersive environments can transform the way we interact with and also the understand data, making the process more aligned with our natural interaction capabilities. Lastly, also immersive data visualization can be used to discovering complex patterns. The ability to step inside the data helps in identifying complex interactions and patterns that may not be apparent in traditional flat visualizations, let's say it. An interesting project we are seeing is this Nanom. It builds intuitive software aimed at democratizing science, engineering, and research by leveraging the latest in virtual reality and blockchain technology. Their tools help us innovators better visualize complex data by these 3D immersive applications that can facilitate faster pattern recognition through an efficient design process and global decentralized collaboration. Well, so as we see under this data visualization topic, we have seen a couple of immersive environments approaches and advantage that these powerful tools for data visualization can bring to us. I think especially as the data sets become increasingly complex and voluminous. So these platforms also brings new perspectives on data analysis, making it possible to uncover insights that might otherwise remain hidden in traditional analysis methods. Thank you.
Thank you very much, Fernando. It's quite impressive. It's not, I mean, this is real. I mean, in the sense, this is real tools. It's not like something you see in the movies.
Yeah.
It's
real
actually
data.
Yeah, it's real data. And for digital twins, obviously this looks to be a very powerful tool. We will come back to discussing this. I just want to show you the results of the poll that I did while you were speaking, Fernando.
Yeah.
And we were asking, have you used immersive data visualization? Simple as that. And 25% of the audience actually have used it. And we have the ballpark is actually interested in using it, 63%. And some are on the fence. I'm not sure, probably because it might not be possible or relevant even. Yeah. So thank you very much for participating in the poll. It's very useful for us to have this information, and I'm sure, Fernando, you also appreciate this feedback. Yeah. So thank you very much, Fernando. And now we will go back to the speakers, to the next part of the program. And I would like to introduce then Jacopo, our next speaker. Jacopo Fabrini, he works as an electronic and telecommunication network engineer, a software developer, etc., at the R&D development of the Academy for Games and Media at the Breda University of Applied Sciences. He is focusing his work on simulations through the use of game engines, which is very maybe familiar to some of us. Unity and Unreal Engine, even I had heard about. I actually played on Unreal, Jacopo. Now we are using it in much more useful ways, and we will learn about a new tool, actually, which it's called GeoViz. And with that, Jacopo, I give you the floor.
Yes, hello everyone. Give me just 1 second to share my screen and the slides. Do you see my screen and the slides?
No.
Oh, no. Wait. Yes, of course. I need to press share. Who would have guessed?
Yeah.
Voila. Now you see it?
Yes.
Okay, perfect. So hello everyone, I'm Jacopo Fabrini. I am going to present to you GeoViz. It's an application developed within the context of Iliad. BUAS, Breda University of Applied Sciences, is the work package leader, work package 6, focus on visualization. And within the context of task 6.4, there have been multiple applications being developed, and GeoViz is one of them, and the scope of this application is to visualize the flow of microparticles in 2D, 3D, and 4D with controls over time. Just to give a super quick, give me a sec. Okay, super quick explanation of where we're coming from. I belong to Cradle, that is the research and development laboratory within the academies of for games and media of Breda University of Applied Sciences. It's a research laboratory which members seems to belong more to a game studio, since we have programmers, artists, designers, producers, but also some geodata analysts and specialists, since we often create simulation concerning geodata. Of course, being within a university, we have researcher and professor that translate our work into research work and papers. Within the context of GeoViz and Task 6.4, we wanted to work closely with a specific pilot within Iliad that had data that we think would have been nice to visualize. Specifically, we've been working with Sintef, and they have in the Gulf of Trondheim 2 buoys. with sensors and specialized camera to detect microparticles that pass in front of them. And on top of the detection, they run some machine learning algorithms to be able to classify the particles that they visualize. Specifically, they can classify cope pods, so little animals, oil droplets, and microplastics. The data that they had were then translated in a 2D visualization through the OpenDrive simulations, and this is the kind of visualization that they were able to have. And the output of this visualization created a netcdf file. So this is the kind of file that we were working with. And maybe who's working with geodata is more confident and know better this file. But for us, being software developers and game developers, we were not so confident with it. So we had to find a way to represent those data coming from this format. First of all, we identified a software solution in the Unity engine, since it had recently released the entity component system. The entity component system is a system that is a framework that is data-oriented, compatible with the game object system. If someone is more confident with the Unity, knows that everything is within the mono behavior and the game object system within the representation. While this system lives besides that, it allows to create optimized large-scale simulation, and this is exactly what we wanted, because sometimes if we just need to parse and to elaborate, to visualize and render the data for 1 day of detection, we will find ourselves to work with a quite large data set. In order to do so, also, we were able to implement the Microsoft Scientific Dataset Library that allowed us in C#, that is the language used to program in Unity, to convert and parse the netcdf into data structure that are used by Unity. That worked quite well, but let's not lose much time explaining what's going around the application. I can show you what the application does, what's the current status. What you're going to see is, again, a work in progress, but we are getting close to release. There's still some stuff they want to add, and I'm going to speak about it later. I'm just going to show you quickly what we can do. Originally, on the first setup, a user can set up an API endpoint to retrieve the data. There's a widget that is automatically set up from the data, knowing latitude and longitude, or the user can set up a personalized widget. And we have the visualization of the location where the data are located, and we give different map visualization. You were seeing before a realistic satellite visualization. Now we have a more similar to a map visualization, and now a bathymetry visualization. All of these visualization are provided by Cesium. They developed a plugin also specifically for Unity. The movement that we allow are similar to Google Maps with the drag and drop, and also with the free camera with the WASD similar to games. As you can see, you can reset the API data. We can also save file or load an netcdf file locally. We allow to have some different kind of visualization. We can visualize the particles by color on the different variables that we are considering right now. Specifically for SINTEF, we're considering the type of particle, the diameter of particle, and the depth of the particle, because these are the data that they made available to us. It's possible then to go underwater and see exactly what does it mean, where they are located underwater. We can also visualize through the darkness of the particle themselves. As I was playing before and I was showing, it's possible to regulate the speed at which the particle moves. And in general, using Cesium, we support the entire world, and the location and the generation is just dictated by the position of the particles, and that position is determined by the data themselves. To quickly wrap up, sorry. Okay. Future developments for the application. As I said, the application is a work in progress, but we are close to be ready to release it on the Iliad marketplace. There's some final feature that needs to be implemented. First of all, the retrieval of the netCDF from an API endpoint, meaning that right now we are working locally, so we're able to load locally a netCDF file and convert it. We already prepared the UI and also the code base to send the request and then retrieve the file. We are waiting to adapt to what Syntef is going to provide us. And after that, since Syntef is also working within the context of Iliad, we're going to adapt to the standard that they decided to follow, and we're going to use it as a generic standard for all people that want to provide their data. Then we want to do dynamical filtering of particles. This means at runtime, you're able to see, to say by selecting the different toggles on the left bar, I only want to see the particles under a certain depth. I only want to see the particles that are copods. I only want to see the microplastic. I only want to see the particles that are larger than this size. And of course, we need a general polishing just before release. With the release, of course, we're going to include also an extensive documentation focusing on which kind of format the netCDF file need to have. Because, of course, we try to be as generic as possible, but we cannot support everything. We need to have a specific structure of the netCDF file, and we are going to adapt to what we decide it's going to work with Syntef, and then use that as the standard for the application. And of course, also the format of the JSON response that we expect when contacting the API endpoint where we retrieve the netCDF file. And we will release a manual of the application, specifically with the camera controls, since coming from a game background, it's easy to use a WASD controlled camera, but it might be better to explain a bit in depth how it works, and also some specific feature like being able to recenter the camera on the origin of the particles and so on. And I want to thank you all for the attention. This was GeoViz.
Thank you very much, Jacopo. It's very impressive, actually, that you can follow the particles this way, visualize and follow the particles in this way. We can come back to the potential use of other parameters as well. I posted a poll while you were speaking also, Jacopo, and here you can see the results. Will GeoViz generated visualization be useful in your work, was the question. And you got 41% yes and 38% maybe. So this is highly relevant for the audience
It's
today.
an amazing result, no, for
Yes,
us.
yes. I think it's a need. We have identified a need here. And actually the last one, nobody say no. It was, I'm not sure. So they are, evaluating whether or not this will be relevant, I guess. Anyways, you see that this tool will be useful and appreciated. So thank you again to the audience for participating in the poll. It's very useful for us to get these results. So thank you, Jacopo.
Thank you.
And now, yes, and we'll stick around for questions. Now, last but not least, we will see an example on how this can look like, visualization can look like in one of the digital twins we have in Iliad. And we have Ricardo Pereira to do this introduction. And Ricardo is an aerospace engineer, and he is specializing on wind, energy, and aerodynamics. And currently he's working at WaveC. And also at the same time, he's a professor at the Lisbon University. And we have a musician among us. So welcome, Ricardo. The floor is yours.
Hello, everybody. Can you hear me just fine?
Yes.
Yes. Okay. So first of all, thank you, Bente, for the introduction. Hello, everybody. So I will present to you in a very short fashion a little bit of what we are doing with our pilots, with our application within Iliad that we are developing at WaveC, and trying to, let's say, enhance or to talk more about the visualization aspects. Okay. 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 So, first of all, what is our pilot about? So pilot, I guess most of the people know here already what this means. Just in case somebody doesn't know, it's what we term the little elements, the little units that comprise the enormous digital twin of the ocean. And the idea, of course, was that each of these pilots represents a small or a large aspect or functionality or application of the whole ocean, which of course is a rather ambitious task. So to tell you a little bit first what we are doing with the pilot, what it's supposed to do. So the name of the pilot already says it all. It's called STOMP. STOMP standing for Short-Term Operation and Maintenance Planning of offshore wind farms. So basically, essentially what this does is what we are trying to do here is that we try to optimize, in the sense, try to arrive at the ideal sequence of maintenance operations for a wind farm. In terms of a development or development stage, let's say, the application is online and is featured in the Iliad Marketplace Twin Lab, even though core model improvements are still being implemented. As you know, as a scientist, it's a never-ending task. Now, what is it that we, how do we do this optimization? Well, as we are saying here, it's short-term. So short-term means few days. Few days, meaning that we require the weather forecasts to assess which, first of all, whether or not the operations are possible. This is the first thing that needs to be checked out, according, of course, to the meteorological parameters, especially the wave height is one of the main, let's say, one of the main factors that determines whether or not it's possible to do some maintenance. And we also consider, so the weather forecast is one important element. Another important element is the vessel fleet availability, meaning which vessels are available. I would just, which vessels are available to do your maintenance. And of course, the characteristics of the farm itself. This has to do, I put here a little map, so in which one of these, each of these crosses here ideally can represent a turbine. And what this means here is that especially according to the wind directions, as you will see in a little bit, you might want to change the sequence of operations, again, because there are aerodynamic interaction between the turbines, namely what we call wake effects. As such, generally speaking, you want to intervene, to make the interventions on turbines such that you minimize the energy loss. And in other words, we try to minimize the costs, because you minimize the energy loss. So of course, you also minimize the costs of your maintenance operations. We are focusing specifically on, this methodology is broad and is generic, but we are focusing specifically in a case study with metocean data from the Portuguese Weather Institute, and with the layout of the farm corresponding to a wind farm, as indicated here, an offshore wind farm in the north of Portugal. Well, I also have this architecture slide. I know that probably it is not the most interesting for most people, or at least for some people, maybe not so interesting. This is, according to what we within Iliad are, let's say, categorizing the different elements, the different components of our pilot, and also according to the different, work packages involved and the different, let's say, steps or phases. And this also indicates the sources of data that we have, namely external data sources, the Portuguese Weather Meteorological Institute, which actually gathers data already from Copernicus, the data lake component, and then the hardcore, let's say, model component, then the core of the model, and then finally the visualization here, which is, let's say, has two branches, let's say, which is what I'm going to refer to now. So the first branch is this web application, and I will very briefly show a little bit of the video that we have to present this this application. So I will just play it here just for 30 seconds or so.
And infrastructure. To showcase the application, we will create a new project from scratch. We import geographic coordinates, in this case corresponding approximately to the wind-float Atlantic wind farm, 20 km off the coast of Viana do Castelo, in the north of Portugal. The data is retrieved via an API. The variables required by the application are the wind speed and direction and wave height. In this example, the forecast data is retrieved from the Portuguese Meteorological Institute, with the source for wind data from the ESA Sci-Hub and the wave data from Copernicus. The spatial resolution corresponds to approximately 2 km, and the forecast is updated daily. The user must also input the distance to port, and the spacing between turbines. This is required to estimate the travel times and thus operational costs.
Okay, this was just to briefly show you that the application exists. Okay, now we can go back to the presentation and tell you a little bit more about the visualization component. This is kind of some screenshots of what you just saw. So here I'll highlighting the different inputs that the application needs. Namely characteristics of the wind farm, of the vessels, the electricity price, the lists of activities you actually want to carry out, and of course the weather forecast, without which you could not plan any maintenance operations. And here we show some results. In this case, of course, this was for a specific case with a specific weather forecast for a specific date. But like I mentioned, like was mentioned in the video, there is an updated weather, or the weather forecast is updated daily, so once per day. So again, this is continuously being updated. What we are showing here in terms of visualization, and I think it helps to understand, this is a costs breakdown of the different elements for this specific. In this case, was 3 maintenance operations. You can see here, and the date in which they were scheduled, and the time of the day. And of course, there is the ability to do some interactive cost visualization. Namely, as you can see, this was for the same simulation results, but of course, if you toggle on and off some of the components, then you can have a different pie chart, essentially, is what we have here. Now, another aspect within the web application that we also think it's important to visualize is the weather parameters, or the weather forecast. We show hindcast and forecast. We're showing here, and we could pick here, in this by selecting sea wave height, or wind speed, or mean wave period, etc. And essentially, we have these black dots represent the hindcasts, and these blue dots represent the forecast. And I just show briefly these two here. Again, the wave height is especially important to determine whether we can whether we can do the maintenance operations, so to determine the workability. And the wind speed and direction is used to determine the best set of turbines and the best time slot to do this maintenance, again, because of the aerodynamic interaction between the machines. Now, the second element I want to show you about visualization is what we are working on in Procedural Ocean. So Procedural Ocean, as probably you are already aware of, is a tool developed by BUAS, so by the Pereira University of Applied Sciences. And I'm not let's say, I'm not the expert on this visualization technique. I can tell you, however, that it is already, as you see, producing immersive visualization, and it allows us, it's actually super beautiful. Of course, we also specifically for this case, we chose the sunset hour because everything looks better at sunset, right? But we see here a little bit of what we can do, and already, I mean, what we are doing here, it's a short video. What we're doing here, we are changing the wind speed, and then the turbines respond accordingly. So when we go for a very high wind speed above what we call the cutout wind speed, the rotor just stops turning, and then when we decrease it again, it turns again. So how are we developing on this? Well, in terms of pipeline, what we are talking with BUAS specifically to, let's say, approach our web application and to kind of join with the Procedural Ocean to have something closer to a digital twin. There are these three main points that we are looking forward to and working on. One is to have a wind farm that corresponds to the wind farm that we actually consider, which is, like mentioned before, in the north of Portugal, or a rather small wind farm with just 3 turbines and with a floating platform like we see here. Another point that we are working on is to have a CTV animation. CTV means crew transfer vessel. So these correspond to the vessels that are used to do the maintenance. And this maintenance intervention is not yet, let's say, included in the Procedural Ocean tool. So this is something that will be done, I believe, in the next couple of months. And the other point that's very important to make it, close to a digital twin is to have a connection to Procedural Ocean via an API that provides the weather, namely the wave heights and the wind direction, but especially the wind speed, and also the cloudiness, so the amount of clouds, such that we can have a real-time representation of the wind farm. Well, what we would like to have, if we had a perfect world, I also put here in the wish list. Not only we would ideally also have a floater closer to what the real wind farm has, but also we would be absolutely thrilled if we could have a larger wave amplitude range, because at the moment the maximum height is 1 meter, significant wave height, and that is rather small compared to the sea states that we can effectively expect. Well, this was more or less what I had, so I thank you for your attention. If you're curious about how we created the avatar that we saw, because it's also about visualization, I guess we can also talk about that. But now I'll leave the floor to Bente, please. Thank you.
Thank you so much, Ricardo. It's indeed very inspiring to look at how we can use this visualizations tool in a concrete digital twin of the ocean.